Introduction. Point Pleasant Park background. This park holds significant importance culturally, historically, and traditionally for Mi'kmaq people and residents of Halifax. It is a large forested municipal park in the southern Halifax Peninsula. The effects of Hurricane Juan. Hurricane Juan took place in September 2003 and resulted in 70% of the trees being uprooted in Point Pleasant Park. This led the ecosystem to go under secondary succession. It was a Category 2 hurricane with winds of 100 miles per hour. The park remained closed for 8 months following the hurricane.
Objectives and hypothesis. Our objective in this experiment is to evaluate the secondary succession following Hurricane Juan and to observe and measure community metrics to predict the future of Point Pleasant Park's forest. Our hypothesis is that following Hurricane Juan, species richness, Shannon diversity, and total forest density will increase until the forest community climax is reached, whereas P-loose evenness and diameter at breast height will decrease until the forest climax community is reached. Materials and methods. Data collection. For our experiment, we used 6 sites as replicants to measure various aspects of the secondary succession in Point Pleasant Park. These 6 sites were chosen for the experiment due to being the most impacted areas from Hurricane Juan. Each site is 20 meters squared in size. All trees with a diameter at breast height of over 2.5 centimeters were identified and measured. Note that for this experiment, the diameter at breast height was measured at a height of 4.5 feet. For each individual site, both tree density per species and tree size in centimeters at diameter and breast height was recorded. For the data analysis, using Microsoft Excel, species richness, species diversity using the Shannon Index, and community evenness using P-loose evenness index were calculated and graphed. Over the period of 2004 to 2003, except 2005 due to Hurricane Ophelia, 2007 due to Hurricane Noel, 2016 due to Hurricane Matthew, and 2019 due to COVID-19, changes regarding tree density, size, and dominance were gradually observed and used to construct a linear regression analysis. The reason a linear regression analysis was chosen is to relate the tree characteristics to time in order to observe the effects of succession over the course of many years following the Hurricane Juan's impact.
Results of Question 1 and Question 1. How has the overall forest community changed over time? Why? What can we predict will happen to the overall community as the forest moves towards its climax community? And why? Figure 1 depicts a graph showing the diameter at breast height of trees in Point Pleasant Park measured between 2005 and 2025. The data was collected annually by Biology 2060 students. The graph shows a decline in DBH from 2005 to 2025. The explanation behind this is that the older a tree, the greater the DBH. Hurricane Juan wiped out many of the older trees, and the majority of the trees measured after the hurricane, after 2003, were planted after it as well. We can predict that the DBH will increase over time as the trees are allowed to grow uninterrupted.
We also looked at the dominant species within Point Pleasant Park, red spruce versus red maple. And so linear regression was used to analyze the density data of red maple and red spruce trees from 6 different sites across Point Pleasant Park, Nova Scotia, to see how populations regrew after the destruction from the 2003 hurricane. Density data has been collected from the park for the past 21 years by Dalhousie students and teaching teams. Red spruce trees showed dominance in 2004, while red maples have taken over for dominance in the last collection of data from 2024. Tracking how the tree populations change and evolve will give scientists a better understanding of the forest succession and direct impact of mass destruction on repopulation of certain species. So for the red spruce trees, the density of red spruce trees has increased around 34% in the last 21 years in Point Pleasant Park following the destructive hurricane in 2003, with a p-value of 0.009. And then for the red maples, the density of red maple trees has increased around 256% in the last 21 years in Point Pleasant Park following the destructive hurricane in 2003, with a p-value of 0.002. So here are some predictions for what will happen with the dominant species in the future as the forest moves towards its climax community. So, while red maple numbers have increased significantly since the hurricane and are currently the dominant species in the forest, the rate of increase is significantly lower when compared to red spruce trees. We have 0.34 versus a 2.56 rate of increase. Red spruce trees were dominant at the start in 2004, and while there have not been nearly as many, red spruce tree density is increasing at a much higher rate. If they keep increasing at the same rate, red spruce trees will be the dominant species again in time. In 1984, a forest management plan was created, and red spruce trees were recognized to be one of the most dominant species in the park, along with softwood strands. This past account of red spruce dominance further supports this prediction.
How has the species richness in Point Pleasant Park changed over the 19 years of its observation following the impact with Hurricane Juan? First, a linear regression analysis was performed on the data to relate the effect of time with species richness. As seen in Figure 3, there is a positive trend line with an R-squared value of 0.6051, which indicates that the secondary succession is indeed positive and that as time passes, the species richness is steadily increasing. This is because after the hurricane passed, there were plenty of unused resources and less competition due to the death of previously growing vegetation. Thus, a variety of new species could move in to thrive on these new environmental conditions. As more time passes and the forest moves towards its climax community, it is predicted that there will be fewer species establishing themselves in this environment, and if plotted, we would expect to see a plateau in species richness. This is due to decreased resource availability and increased competition, and thus species could potentially undergo self-thinning.
So, for some conclusions, the current succession stage of the Acadian forest in Point Pleasant Park seems to be in the early stages. As the majority of wildlife was destroyed in the 2003 hurricane, all the new trees and growth are still very young, proportionate to the average lifespan of species such as the red maple and red spruce, which can live for hundreds of years. Since there's a lot of trees still only around 20 years old, the forest as a whole would still most likely be in the early stages of succession. And as Point Pleasant Park is an urban park, it faces its own unique challenges when dealing with succession. So different types of human disturbances to the forest, such as destruction of wildlife from walking and human interaction with the plants and wildlife, could have an impact on how they grow and develop. One study looking at human disturbances and forest succession showed the impact that humans had on other wildlife and fires that in turn affected how tree species interacted with each other. Because Point Pleasant is an urban park that is contained in a certain area, it is more susceptible to mass destruction. Large parts of the forest being destroyed as they were in the hurricane can set back succession, as you're destroying the whole community, not just a little part of the forest. And that can keep the park from reaching its climax community. And different indigenous perspectives and views can add a lot to ecology. So a certain Mi'kmaq teaching that I wanted to highlight was called Nedugalimic, which is about interconnectedness, appreciation, and it can lead to a change of view. So it's about how all the different aspects of your own self interact with the world around you, and taking in this knowledge could assist in the way people view the park, as it is an urban park, so being able to appreciate the interconnectedness that you have with the land around you, whether you're in the park or in the city, is something that you could take with you. But specifically being in the park and being able to be cognizant of what's going on around you and the different ecosystems at play is super important, and that is something that could add.
Acknowledgements. We acknowledge that Point Pleasant Park rests upon the traditional and unceded territory of the Mi'kmaq people, and that all data collected was collected on this territory. Furthermore, we thank the previous students who collected the data and used for the regression analysis. We thank Dr. Allison Schmidt for performing the regression analysis, and we thank Dr. Allison Schmidt and our TA for assistance in our research.